Hello and welcome back to Math Chat Podcast, teacher friends. Mona here. Today, we are continuing our series on creating classrooms of problem solvers. There's 6 strands in this friendship bracelet that we're weaving. I don't know if I'm going to stick with the friendship bracelet idea, but I'm going with it for now because each of us can braid and weave our own community of problem solvers in a different way, but using the same 6 strands. In this episode, we're going to dive into something that I think math education has gotten really twisted over the years, fluency. Because when many people hear the word fluency in math, they immediately think speed, time tests, flashcards, memorization, getting that answer quick, right? Teacher friends, that is not the kind of fluency that we are talking about here. And I also wanted this episode to come right after the thinking routines, which was the last episode 215, because a lot of times our thinking routines are part of our fluency instruction and building that fluency. A few years ago, I got my hands on a book that really shifted my thinking about fluency. It's called Figuring Out Fluency by Jennifer Bay Williams and John Sangiovanni. Their definition of fluency completely changed the way that I thought about supporting students in mathematics. Now, I will say prior to that, I was working on fact fluency with my students in different ways, but I was still giving assessments in kind of the old school way of giving time tests. But when I read their definition of fluency about developing a repertoire of strategies, I was like, check, we do that in Word Problem Workshop. My kids have so many strategies. This part is what changed for me, that they can use accurately, flexibly, and efficiently. And I was like, are my students using their strategies to be fact fluent, accurate, flexible, and efficient? Loved it. It's not just about getting the answer quick. That's what changed because we're not creating classrooms of calculators, mimickers, or students who simply memorize, right? We're creating classrooms of problem solvers, students who can reason, make connections, who can think flexibly when they encounter unfamiliar problems. And that kind of fluency, that's the kind of fluency that develops through understanding. The real purpose of fluency is to be able to get the answer, but have it all built on understanding the math, right? Not just that you've memorized a bunch of facts. I think sometimes fluency instruction becomes like a bit disconnected from actual math thinking. Students practice facts, right? They don't understand those relationships behind the facts. They memorize the answers or even just like the procedures or the patterns. They don't know why they work. Students become dependent on tricks instead of reasoning. But true fluency is deeply connected to conceptual understanding. So, as we know from adding it up, helping children learn mathematics, mathematical proficiency is made up of 5 mingled strands, which looks a little bit like the friendship bracelet that we're building for our community of problem solvers. But adding it up is conceptual understanding, procedural fluency. They have to have those two to be mathematically proficient. They have to have strategic competence, meaning they know what strategies to choose for what problems. They have to have adaptive reasoning, meaning they can adapt their reasoning when new challenges or new twists come up in problems. And they have to have a productive disposition. And all those things are connected. Procedural fluency does not exist by itself. Students develop fluency through reasoning and strategy development and discussion and sense making. That's why purposeful fluency matters so much as one of our strands. Here's what I'm talking about. This is our friendship bracelet that we're braiding. I want all of you to have all of these. And today we're talking about purposeful fluency. But it goes right along with strategic instruction and word problem workshop and thinking routines and building belonging and identity and student engaged assessment. Let me tell you something I see all the time. Students often believe that math is about remembering steps, being fast, and getting for anyone else. And honestly, that's the belief that shuts most kids down, especially kids who process more slowly, who need time to read, who maybe think visually, still developing confidence or strategies. But fluency interrupts that story, okay? Suddenly now, fluency is going to become about noticing patterns, making connections, choosing strategies, explaining your reasoning flexibly. And that's a completely different experience for kids. I'm bad at math because I don't know my facts fast. I'm slow. Begins to be, oh, I know that multiplication groups of ways to solve problems. And that's really important for mathematical identity. Let me just be clear about what purposeful fluency is not, because all of what I've been talking about, but it's not about time tests every week, forcing memorization. It's not about rushing students or drill without meaning or creating anxiety or need, but it's also not time tests. It's also not checking kids under. This matters. Repetition matters. Type of practice that we matters too. If students are simply just memorizing without relationships, that fluency is going to fall apart. That fluency won't last. What purposeful fluency is seeing patterns. The doubles plus one. If they know 6 plus 6, then they know 6 plus 5. Building strategies to figure out and be able to, like a make a 10 strategy or a compensating strategy, being able to discuss your idea, meaning how you know the answer, making connections between the fact, the concept, and the model represent that. It's explaining why the strategies work and is helping our students develop that flexibility so that it's intentionally an approach that will work. And this happens a lot through thinking routines, through and discussions, not necessarily centers or skills or in apps. But I do love a fluency app. Now, what could it look like? Let's talk through a few examples for thinking routines. That builds fluency. This is where a teacher presents a sequence of related problems or expressions designed to help students notice patterns in relationships. So if we have 8 plus, then we can do 18 plus 7. And if we can do 18 plus 7, we can do 18 plus 17. And then we can do 38 plus 17. They solve and they discuss what they notice, change how they did it mentally. The goal is not just the answer. The goal is helping students see how I build and connect. Okay. Students will say, analyze expressions or equations like 48 plus 27 equals 47 plus 28. True or false? And then we can talk about that commutative property. Or 36 times 5 is equal to 18 times 10. Justify if this is true or false. Explain. Use critical thinking and fluency. I love which one doesn't belong, which is a perfect strategy here. We could do something like 49 plus 21, 50 plus 48 plus 22, 50 plus 19, and talk about all ways that each of those do or do not belong. There's no single right answer in which one doesn't belong. So kids can find all the why they don't belong. I can go on and on, but I'm going to share 2 more. Choral Counting, one that is incredible for helping students see patterns in numbers and structure. Students count together while the teacher records the numbers strategically, place value relationships, patterns and operations, skip counting structures, repeated reasoning. And because it's all together, students feel safe, participate. And then another one that builds so many skills is counting. I love this one because it's thinking so beautifully. And it's one of those rich experiences that builds fluency, but also conceptual understanding and reasoning and all the things. Students count a large collection of objects using strategies that make sense. Some students might count by 2s, others might make groups of 5s or 10s. Then students discuss how they counted, what strategies were patterns they noticed, how they grouped, and how it helped them. And the discussion is the learning. So many games. Okay, those were all things. Collections is just a bonus. And then there's routines. I'm sorry. And then there's games. Games can be so fluency. Things like 100, where it's combine numbers to get as close to as 100 as possible. If you teach an older grade, it could be 1,000, 10,000. To make this number, students are given a target number. I like to call this one today's number, but it could be make this number, whatever. Okay. I just want you to keep it in mind. Fluency is about connecting ideated facts. Flexibility is fluency. The biggest mistake that I see is that students rush before they develop understanding. We often teach procedures too quickly. We overvalue, move students away from their own strategy too soon. But flexibility develops before students need to reason and model and discuss and compare strategies over time. And honestly, fluency will come when students have a deep understanding. Purposeful connects so naturally to word problem work is the same, helping students develop that flexible mathematical thinking. Inside word problem workshops, students are reasoning and discussing and choosing connections with a complex challenging word problem. And purposeful fluency strengthens those habits. When students can think flexibly about numbers, then they're better able to complex problems, explain their reasoning, and adapt strategies to new situations. So how can you start? Because the school year we want to be full in our fluency instruction. Let's keep it full. You do not need an entire new curriculum or long fluency block or materials. I just want you to choose one routine, one game, or one intentional discussion move. And slow down. Most importantly, slow down enough. Asking how do you know? How did you solve it differently? What strategy helped you be efficient? Because the real of procedural fluency is not, we carry those around in our pockets. It's about developing students who understand mathematics, reason flexibly, and trust themselves as thinkers. Students are unfamiliar since that's that lasts and the kind that students need for the real world. And if you're this and you're thinking, yes, this is the kind of math, then what I want you to know is that these are the kinds of practices that we are building inside the problem workshop. If you are listening in the summer of 2026, please join our book club at monamath.com/book-club. The link is in the show notes. We are meeting live 3 times this to discuss the book and all this is inside. Get all your questions answered so that you can start right away this school year. The book and the training help teach their students in developing strategies so that it builds understanding how to engage students in productive struggle because classrooms of problem solvers built through memorization alone. They're built through consistent opportunities for students to think and reason and make sense of mathematics every single day. So here is what I want to leave you with. May you remember the fluent speed. May you create opportunities for students to build flexibility, reasoning, and competence through meaningful math thinking. And trust that when students develop deep mathematical fluency can grow naturally from that understanding. I'll see you next week for our next strand in creating a club of problem solvers. Bye for now.